Good morning and welcome to all our participants taking part to our webinar. Today, I will have the pleasure to introduce our brand new product, the ePDM 7050, which we just presented on Agritechnica a few weeks ago. My name is Arnaud Wendling, and I'm in charge of product management for electronic controllers at Würth Elektronik ICS. On behalf of the whole team, I would like to thank you for your registration and interest on our products. It's always a pleasure to host such events. But before we start, let's agree on some organizational topics. Please note that you will be muted during the whole live session. But if you want to ask questions or make remarks, you can use the question function from GoToMeeting. Please note that you will be muted and that the presentation will take 25 to 30 minutes. Then we will answer your questions in a Q&A round. Of course, if there is any question left after the webinar, we will get back to you directly. And lastly, we would be pleased if you could give us some feedback after the meeting. There will be a pop-up window with a short survey opening automatically when the webinar ends. A few words about the GoToMeeting tool. You will be able to change the language as you need by clicking on the small globe on the toolbar. You can open and close the interface with the red arrow. And the most important feature would be the question box. Don't hesitate to use it during the webinar for asking some questions and during the Q&A session especially. And without further ado, let's dive into the agenda. On today's webinar, we'll firstly introduce our new electronic power distribution controller, the ePDM 7050. Then we will have a look at the WEcontrol Designer, our programming environment. And lastly, I will present the services and solutions we can offer to you. First, I would like to present you with the evolution of our product range. On the left-hand side, starting with our core power distribution systems, we have our regular and always customer-specific power boards, equipped with fuses and relay, and to whom we can easily add the ICCS product range, like our 64P, to offer a first level of control and diagnostic features. And in the last years, we introduced two types of new products. In the center column, you will see the CDM A16. This pluggable controller perfectly fits our red line box platform and supports the diagnostic and multiplexing into those boxes. Then we have an hybrid solution, combining electronics and electromechanical power distribution within our 8FR6 using our medium box. And this leads us to our topics today, to our electronic power distribution solution, the ePDM, a full electronic device providing logic processing, communication, and high power outputs to our customers. I will come back to the topic a little bit later. Of course, our ePDM 7050 is a new type of controller, combining digital and analog inputs and a large quantity of outputs, providing a new approach to the electronic power distribution. The key role of this product is to distribute power from battery to all the different loads in the system, including even a full chassis or powertrain or cabin supply with its high power outputs. The idea of this product is to be located upfront of the electrical system. Thanks to its several wake-up inputs, it can handle all the wake-up scenarios you can think of. We can think of such scenarios as to use the door switch to to supply the dash HMI, thus eliminating the boot time delay for such devices. And this while turning on the steps light for the driver to access the cabin. We can as well plan many typical loads being directly driven from the device and simply control over CAN bus. Of course, the device being a controller, we offer a wide range of possibilities in terms of programming features, as well as some standards on the market UDS flashing protocol. I will come back to the topic a little bit later, but this device also provides so-called always-on outputs. So its outputs are activated even if the device is in sleep mode, capable of providing energy to different types of loads. We rely on the hardware protection of the SmartFET to protect the whole system. The idea with such outputs is to provide a protected energy source to systems like a telematic device, being then able to wake up the ePDM to access some devices within the vehicle to gather information or start some functionalities from a remote location. Would it be nice to be able to locate one single machine on a parking lot full of dozens of identical machines by just activating the warnings? The ePDM offers a large variety of outputs and a limited amount of inputs. You will find 9 analog inputs covering different voltage and current range. 3 5 volt, 4 16, and 2 20, 0 to 10 volt or 0 to 20 milliampere on the digital input side. You will find 3 frequency input, 7 digital input high active, as well as 3 digital input low active, which 2 high active and low active are acting as wake up inputs as well. But it's on the output side where the things are getting interesting. Our ePDM offers up to 38 outputs. We have 2 300 milliampere low side outputs. The idea behind those ones is to control some power relays outside of the electronic switching capability. Then we have our always-on outputs. Those, as I stated before, will act as a regular output when the device is running and can be turned on and off based on your logic. But when the ePDM goes to sleep, you can decide if you want those outputs to supply your load or not. On the medium power range, you will find 10 of 3 amps and 10 of 10 amps outputs. You can set a PWM on half of those outputs. Then we offer 8 9 amps output, all of those providing PWM capability. And finally, the 3 35 amps outputs. Those outputs can be used to supply your larger loads as part of your vehicle, giving you the ability to manage the power supply on a more global way. Oh, and I almost forgot, we have 1 4 ampere full bridge output. To be used with our 5 volt analog inputs, we do provide a switchable 5 volt voltage reference on the device. To communicate with the rest of the system, the ePDM is equipped with 2 CAN buses. The first CAN bus is used for support of UDS flashing protocol and live debugging mode from the WEcontrol Designer. The ePDM is capable to operate in the roughest environment from -30 to +85 degrees Celsius. And when speaking about the continuous load, the ePDM, it is capable to supply 150 amps at 70 degrees and 120 amps at 85 degrees. I want to highlight that these figures are within an enclosed area, without airflow. Any airflow or cooling solution which can be applied on your system will give even more efficiency on the current capability. Finally, we designed our device from the electrical point of view as for the housing to survive through the roughest environment with an IP6769K and a high reliability of over 10 years. What comes to mind when we are speaking about power distribution system is, of course, the fuses. And within the ePDM, we aim to propose a comparable behavior to our well-known fuses. We all know that the fuses will not blow at the nominal value. If you take, for example, a 10 ampere fuse, shown in the red line, you can apply a load of 15 amps and it will take 10 to 20 seconds to blow. The ePDM aims to offer a programming block for our customer to configure this behavior. This block provides a complete diagnostic of the output stage. It manages 3 different states to define the output health. The first one is a normal area. The current flow is within the defined expectations, or what you just programmed. The second area would be a light overload. This will allow the ePDM to withstand a programmable overcurrent for a limited amount of time. For example, you could accept 20 to 30% more of the output to be delivered for 2 minutes, allowing the system to return an information and a warning to the whole system before taking the decision to cut the output to protect your wiring harness. The third area is defined as high overload. It will allow a much higher amount of current, but for a very short amount of time. This feature is fully programmable from our programming environment, and it can be fine-tuned based on wiring harness and load definition. If we speak a little about the mechanical aspect of the ePDM, we are using a Tyco-Levi-Steel connector family. We have 2 different connectors, a 31-way and a 39-way, offering 70 pins in total. And those connectors are color and mechanically coded. The back part is made of aluminum, playing the role of heatsink. With ripples, it allows us to manage a high amount of power we can dissipate into the module. So let's discuss together a little bit about the advantage for your next generation of vehicles. The first being the flexibility. With a software-driven device, the ePDM can evolve in features and behavior through a software update. It can even be implemented several times in the vehicle and can combine any type of logic or communication to drive the outputs. We reduce the global electrical implementation cost. Follow me on that. The wiring harness gauge can be adapted to the load. If you think about it, how do you select a wiring harness nowadays? If you take, for example, a 7 ampere load, you will protect it with a 10 ampere fuse. And if you have such a fuse, you will need your wiring harness to be defined for at least 15 to 20 amps, as you don't want the wiring harness to be the weakest point. So we end up with a factor of 2 or 3 between the nominal current for the load and what is selected for the wiring harness, thus costing weight and money. On the ePDM, you can then define from the programming environment how much current you can deliver on the output, on each output. You could even reduce the expected current to match the load by using a more powerful output for a lower value. We can standardize as well the electronic system. Having a standardized module on the shelf, you can multiply the implementation in your vehicles or in a wide range of vehicles, optimizing by using the same wiring harness over a complete range of vehicles. The small changes in behavior can be covered by programming in that case. Fourth point, we can offer a wide range of diagnostic on our module. We could, for example, count the number of activation, or we can count the operational time for each output, and we can save it in the FRAM of our devices. The ePDM being placed uphill on the electric system, we can offer an enhanced user experience. For example, we can make several devices like door switch on HMI straight activated when you open the door without doing anything else, or we can be woken up from the telematic system just requesting a given ECU to be powered on to gather the diagnostic values. Of course, those different scenarios are completely programmable within our programming environment. With the ePDM and its advanced protection stage, you will not be needed to replace the fuse. Therewith, no direct access is needed to the ePDM. The device can then be buried in the construction of the vehicle because you will never have to access it directly again. No opening on the plastic parts to access, no complex design of access panel to be integrated in your cabin. Next point would be the cost reduction on the wiring harness, which we explained earlier. We can think a little bit the cabin differently, allowing HMIs and CAN keypad as main interface with the driver. There will not be a need to move the power through the cabin anymore, going from a battery to a rocker switch and then back to the load with thick cables. As well, we all know that the rocker switches are reliable and can switch high current. Thus, they are costing quite a lot of money. And last point, we are not intended to be your master ECU, which means that we aim to switch on and off the loads based on the CAN communication. You may have instead of dedicated ECU with a limited amount of inputs and outputs. We could free some of those outputs by taking care about all the lighting and all the different functionalities, allowing you to reuse those for more machine-dedicated features. I hope I could explain the concept behind the product clearly. Please, if you have any comments, don't hesitate to write some question in the GoToMeeting interface. I will come back to those at the end of the webinar. Now that the ePDM is known, let me shortly introduce the WEcontrol Designer, our programming environment. This tool is supporting all our 32-bit platform, CPUs and controller, which are the CDMA16, the 8FS6, and of course the ePDM. On the very lowest level, we have a bootloader which uses a UDS protocol to flash a new application onto the device. The second layer will be our firmware, where we support functionalities like G1939, memory attribution, data formatting, and base communication. The third level will be our WEcontrol Designer runtime. This is the interpreter of the source code which will be generated with our tool. It is as well the layer where we integrate our C code, which we then make available for you in the upper layer. And on the highest layer, you will find the application itself. This will be the core of your implementation. We offer in this tool a wide range of possibilities. For example, we offer a G1939 built-in library or a gateway configuration tool, as well as an advanced debugging functionality, live mode, as we say. For the configuration of the system, our tool provides a graphical configuration as well as supporting the IEC 61131-3 languages, known as function block, structure text, sequential flowchart, and ladder. I will not go into every detail, just know that we use drag and drop features for most of the programming, and then we can just configure the functionalities. You can as well create a user-defined function block, which allows you to create some kind of macro functions, which you can recall several times in your application. The simulation and live debugging functionality are brand new in this tool, and this will speed up quite significantly your development time by knowing and being able to gather information directly into the device. And as you can see here, labeled with the number 2, we do offer as well a G1939 library. Just enter your PGN in the function and the matching SPN list will be displayed. You just need to select and give a variable to this device, to this signal, and you can use it in your programming environment. We do offer with this tool an online template management as well as an online target management, which means that you will be up to date no matter what. And if we propose new device to the market, they will automatically be proposed in our programming environment. Here are some examples of structural text, function block, and sequential flowchart. Of course, you can convert from one programming style to another one directly within the programming environment. And finally, we do offer a VA Flasher tool. It supports all of our existing and new controller, as well as a way to configure our 6-way symbol cluster. You will be able to program all of our devices, whatever generation they are from. Of course, if you are interested in a more dedicated UDS implementation in your own tool, we can support you for that. Now that I have presented the new controller ePDM 7050 and its programming environment, which kind of service do we support you with? First of all, programming environment. Yes, of course, for further programming, we can proceed with the programming of your devices for you based on your specification. But if you prefer to create an application by yourself, we can as well support you during the programming or during the learning phase by offering trainings on our toolchain. And finally, whoever has written the application, we can preload the application before delivery of the controller to you directly to your production plan. So we are finished now with this webinar. It was quite rapid and not without some issues, but let's do it like that. The introduction to the ePDM 7050, I hope this gets some interest from you. I already have seen that there are some questions here. So without further ado, let's start with the Q&A session. Yeah, all right. Already some people are asking. So, can you name an example of what vehicle functionalities 150 output can be used? So there is indeed not 150 ampere output. It's the summary, the gathering of all the outputs, and we can manage up to 150 ampere in total current consumption of the device, and that's what the main 150 by 70 degree or 120 amps by 85 degree means. We have a question about the inrush. Are we able to handle, for example, 20 amp inrush current on the 9 amps output? Yes, the inrush, we are currently making the right measurement to perform here, but I think twice the nominal load will not be an issue. Of course, you have as well to take into account how long this inrush is taking care or is happening on the device. So this is a parameter which we have to figure out, depending if it's a lamp, they have normally quite a high inrush, or if it's just a starting of a motor. Of course, you can always, if your load accepts it, use PWM start to reduce the inrush of the vehicles. Okay, we have a question regarding safety. So actually, this device will get the evaluation based on the 13849, so MTTFD, diagnostic coverage, and so on. The CPU which is here used is a S32K from NXP, which is ASIL-B capable. So there is a lot of topics which needs to be taken in account, just not only the CPU. So if we have a more when we will get the figures, it will be put in the datasheet of the product for this device. It is not especially intended to cover ASIL or higher performance level. It can be compared to a power board in that way. So there is a question of combining multiple outputs to achieve higher load. So this is a topic which comes back quite often, and frankly, this is a tricky topic because all the chip manufacturers or SmartFETs are not recommending this use. So technically, it is doable, but we always have some issue in terms of will it withstand for a long time. So we don't recommend it either. In that case, we will push to use a higher power output to handle this. But if you have a special case or some special implementation with the defined load, we can always review this with our R&D to evaluate this specific use case, and we can make sure that the two outputs are activated at the same time in the application. Is -40 ambient temperature also a target to fulfill? So the norm is more -30, -40 will be a little bit out of range, but we can make a check on that. Most of the component will do. It's a matter. Anyway, with the power which is managed in the box, it will not stay long in -40 degrees. What are the dimensions of the box? Is the layout of the twin box? So for the dimension, they will be put in the datasheet of the product, of course. This is a little bit smaller than a twin box, if you want, in footprint. And of course, the pinout is fixed on this device and cannot change. In terms of cybersecurity, so we have here the first evaluation going on. We are looking at UDS with a key protection. We have a whole system of being able to deactivate the bootloader as well if we need to. So this is the kind of direction we are taking. So evaluation are starting in this direction. What is the weight of the product? I don't have the weight at hand. I will come back to this person, which I will respond with the value afterwards. What are the maximum frequency of the PWM outputs? So the PWM outputs, so the frequency are changing depending on how much current you draw on the output and how much duty cycle you want to apply. So basically, as a rule of thumb, we say for the 35 amps output, we can say around 100 Hertz. For the 9 ampere, you will have around 200 to 300 Hertz. And for the 3 and 6 ampere output, you will find around 400 Hertz. Is it possible to extend the ePDM module by another I/O module? Yes, basically the ePDM is a controller. It has two CAN buses interface, so you can easily integrate the whole logic into this controller, and then just have the second device being a slave to the ePDM. I will attach the next question, which is actually what about CAN Open? CAN Open is not yet planned on this product. It's something we can investigate, of course. The device being more uphill in the system, it will request another master to take over the functionalities. So maybe we can discuss this if you are requesting the ePDM as CAN-open master or CAN-open slave. This will be discussed afterwards. But the implementation is not ready yet, so it's something we can plan for the future. Is there a real-time clock in the unit? No, there is no real-time clock in the unit. It was not planned to have a wake up on a given time. It's an interesting feature. We will evaluate that for the next product. Is there a rough estimate on when the ePDM will be available? So we have presented the product on the Agritechnica 2 weeks ago, and we have the first customer sample, which will be available in January. So starting January, we will start the try and buy kit with our customers, where we can provide an ePDM with the needed programming language and license, temporary license, for allowing you to play with the module. Regarding a question about EMC test, so the device will be completely EMC tested, of course, ESD, and will be ECE R10 revision 6 certified. We have passed the test shortly, so the final documentation will be on the datasheet, or in all cases. Do we have current controlled PWM outputs? No. So right now there is no PI loop with a dedicated measurement for the ICs. We are using base PWM functionality here. The product is not directly meant for driving valves, so we are here using on-off status and PWM as a matter of smooth soft start and smooth start. Yeah. But the next product we are working on will have current controlled PWM output. And the voltage range, yeah, I didn't spoke about that. That's true. So as you know, the smart FET industry is mainly driven by the automotive market. So right now we are only able to provide the ePDM with its 35 amps output in 12-volt systems. So the applicable voltage range will be 9 to 16 volts, basically. So the programming IDE is the WEcontrol Designer. This is a software which used the different programming language. It cannot directly integrate C code. So if you may have C code to implement directly, we can implement this and generate some specific firmware for you. When will the datasheet be available on the website? As soon as we close the final qualification and that all parameters are done, we will provide the web page for this product on our website, of course. This product is part of our new product range, which will be the power distribution controller. Okay, there is no new questions. Just wait a few seconds. Okay. So there is a question again about ISO 13849. So the evaluation of the product right now is currently running. We will provide all the metrics needed here. We have an external watchdog. We have a CPU which is, I would say, ASIL-B capable, but the whole system needs to be evaluated in regards of your implementation, of course. But we will be able to provide the different metrics. I would assume PLC may be doable with the device, but here I need confirmation for that. Okay, I think we have answered most of the question, when not all. I would like to thank you all for having participating to this webinar, having taken the time with me. And if you have any other questions, of course, you can always request some information at ics.webinar@we-online.com. And please help us to increase our webinar quality by answering on the short survey after the webinar. Thank you very much for your participation, and see you soon to our next webinar.